All right, this time I'm going to complete the square. So remember, completing the square is turning an equation that is not a perfect square into one. So a perfect square is something like x squared plus 6x plus 9, because the two numbers that multiply to the middle and multiply to the last and add to the middle are the same. And it can be written like this. So this is a perfect square. And that's what we're going to turn this one into. Let's just get rid of that because we need the space later. Right. So what I'm going to do is say, okay, if this was a perfect square, what would it be? So what belongs in this space? I've still got the -3, but then, okay, we'll just leave it like that. So what two numbers add to 10? Well, hopefully you can see it's 5 and 5. It's always going to be half this number. So then if they add to the middle, they have to multiply to the last. So 5 times 5 is 25. But I've added 25 to this equation, which means I've changed it. So I need to subtract 25 over here to balance out what I've done. So then this is now x plus 5 squared. That is my perfect square. And this is minus 28. So this is now the perfect square form of this equation. So let's do another one. I'll just clear this, I think. So let's do another one. So let's look at something in a slightly different form. All right, same thing. It's in the weird form, so I'm just going to rearrange it. So minus x squared, and then this is a positive 4x, a positive 3 equals 0. Now, I cannot make something a perfect square if it's got a negative in front of it, so I'm just going to take this out. So this becomes x squared minus 4x minus 3. So we'll leave it like that. Now I'll turn this into a perfect square. So what two numbers are going to add to -4? Well, hopefully you can see that would be -2. So -2, well, I should have added a bracket there. Let's undo some of that so it's a bit neater. Okay, so what belongs there? I've still got a -3. Something else is going to belong here equals 0. Okay, so for this here, this is going to be +4 because -2 times -2 is +4. If I add 4 there, I have to subtract it here. So now I can turn this. Oh, I've done something very stupid with my brackets. I hope you picked that up. That bracket should be over here because that negative got taken out of all of this. It's really important that the negative stays out there, and I'll show you why in a minute. So this turns into x minus 2 squared. Then I've got my -7 over here. Now this is incomplete. I've got too many brackets, so I need to get rid of my outer set of brackets. So now this looks like that, and this becomes +7 because this negative belongs on this and it belongs on this. So that is what I should have in the end. Now, this is just turning it into completing the square form. Let's do another example where we actually have to solve for x once we've got this type of thing going on. All right, let's have another go. Clear. All right, let's pick another color. All right, so let's look at something like this. So I've got x squared minus 6x equals -2. All right, so for starters, again, it's not the right form. I need to get it all on one side of the equal sign. So I've got x squared minus 6x plus 2 equals 0. Now I can complete this square. So x squared minus 6x, something goes here, plus 2, something goes here, equals 0. So hopefully you can see the two numbers will be -3, so they multiply to +9. So then I subtract 9. Right, complete this square is x minus 3 squared. This becomes -7 equals 0. Now, if I've been asked to solve for x and leave my answer in surd form, I need to move things around now to get x by itself. So I'm going to say that this is x minus 3 squared, and then I'm going to add 7 to the other side. Now I need to get rid of my squared, so I'm going to take the square root. Now, hopefully you remember that you can't just take the square root. You must take both the positive and negative square roots because you don't know if you're squaring something, whether it used to be negative or positive. -5 squared is 25 and 5 squared is 25. So we always take both. Now I have to bring the 3 across. So I've got 3 plus or minus the square root of 7. That is my exact answer left in surd form of this quadratic. So always make sure you do stuff like that. I'm going to do one more example that I didn't do in class, which is very tricky because sometimes we might have annoying fractions. So what if I had a number where the middle term was odd? So if I had x squared minus 3x minus 1. Now this is really irritating because I can't just halve this number without getting annoying fractions. I still do exactly the same thing, but I get really annoying fractions. So minus 3x and then something goes here equals 0. So what's half of negative 3? Well, isn't it just negative 3 on 2? That's half of this. So this times itself belongs here. So I should get plus 9 over 4 minus 9 over 4. Now that is incredibly annoying, but whoops, erase. It's not different. It's exactly the same. It's just irritating. So that makes this minus 3 over 2 because this is, so these two numbers will add to the middle term and multiply to the last term. Again, that's kind of annoying, but it's totally fine. Then I have to put these two things together. So again, you should think about that as a set of brackets. So -1 minus -9 over 4. Well, hopefully you can see that that should be -13 over 4. And again, we're just going to do exactly what we did in the last question. I'm going to bring that across. So x minus 3 on, oh, actually, you know what? I'm not leaving myself enough room. Why does that keep happening? I'm not leaving myself enough room. Let's write a bit smaller. So x minus 3 on 2 squared equals 13 over 4. Bring that across as a plus. Now I take the positive and the negative square root. Positive negative square root of 13 over 4. And then I am going to add this to the other side. So x equals 3 over 2 plus and minus the square root of 13 over 4. And what I really should do is put it all together, but you can also just leave it like that for now. Okay, so hopefully that gives you all of the information you need to complete exercise 1.3.